Hey, how's it going, everyone? My name is Zain, and today I'm going to show you guys an easy way to get through these type of questions on the foundation exam. So when they ask you to apply bitwise operators to numbers, just simple calculations like this can take a lot of time if you do it the typical way that most people do it, where they take the number 56 and then they convert it to binary, for example, and then they apply the operation after they calculate the binary format of both numbers, and then they convert it back to a decimal number, like for example 32. So I'm going to show you guys an easy way to get through all of these, and it's going to work for every single operation. So let's hop in. I'm not sure if this method has been taught as through teachers. I haven't seen it personally, and I'm not sure if it's out there somewhere online, but I figured this out the other day while I was doing my session, and I just went along with it. And yeah, let's just hop into it. So 56. The way I like to calculate this in binary format is not dealing with ones and zeros, right? So I'm actually going to think of this as a sort of summation of powers of 2, which is something you guys should have seen before. So let's say, for example, something like this. This is not the exact answer, but this would be something that you guys probably ended up doing. So we can think about it like that. So where you want to pick for 56, or any number, we're going to want to pick to be able to calculate what would be the binary representation is we want to select the power of 2 such that 56 is greater than or equal to that power, or to that power of 2. So we want to get the biggest power of 2 that we can fit into 56 without going past it, right? Because if not, it would be greater than. So the biggest one would be 32, which is 2 to the 5. And then now what we can do is subtract that out, so we have 24. And now the biggest power of 2 that we can fit into 24 is 16. And now we can subtract 16 from this, and now we're going to end up with 8, which is a perfect power of 2. And that's going to be 2 to the 3, which is 8. So we have 48 and 8, so that's 56. So we're good. We calculated correctly. So this is an easy way to calculate your work, but let me show you why this is a good method just across all the operations. So this worked for calculating 56, but now we're just going to replicate the same process but on another number. So let's do 17, which is the problem, and we're doing OR. So I hope you guys are familiar with the OR operation. So I'm going to put the operation here, and the biggest power that we can fit is 2 to the 4, which is 16, and then the next biggest is 2 to the 0, which is 1. So 16 plus 1 is 17. So now we can end up doing, since we're doing OR, remember that OR, it's greedy in the sense that wherever you have a 1, it'll take a 1. So if right here, if we have a 1 and a 1, we're only going to bring down one of those 1s. So we're only going to consider 1. If we have no 1s, it's just a 0. And if we have any 1, and like a 1 and a 0, a 0 and a 1, we're just going to take that. So we can apply the same logic, but to these powers of 2. And for example, so we don't have a 2 to the 5, so we can just take this one, and right here we have 2 to the 4s. So what we can end up doing is just taking one of them. So let's just write this as we go. So our final answer is actually going to end up being 2 to the 5 plus 1 of the 2 to the 4s plus 2 to the 3 plus 2 to the 0. And this is going to end up being 32 plus 16 plus 8 plus 1. So funny thing is right here is we have 32, 16, and 8, which this entire thing is equal to 56. So we just have 56 and then plus 1. So that's an easy way to calculate that. So this might look like a lot, but it's much easier once you get into certain types of questions. So let's do the next one, 47 and 83. So 47 and 83. So let's just set it up. So the biggest power of 2 that fits into 47 is 32. This is 32 plus, and if we do 16, we'll have 32 plus 16, which is 48. So we can't fit that. We have to go down to 2 to the 3. It's going to be 8. Now we're going to have 47 minus 40, which is now going to be, let's just keep track. So we have 15 minus 8, which is 7. And the biggest power of 2 we can fit is 4. The biggest power into 3 that we can fit is 2. And then the biggest power of 2 that we can fit into 1 is just 2 to the 0. So we're good right there. And now once you hit 0, you know that you're good. As for 83, we can do the same exact thing. So the biggest power of 2 is 2 to the 6 plus, and the next biggest, since we're going to have 83 minus 64, this is just 19. So the biggest power is 16 that we can fit into 19. And we're going to have 3. The biggest power we can fit in is 2 minus 2, and then into 1 we can just fit 1. So 2 to the 0. And now we're good. We've calculated all of this. So now at this stage, what we can do is just find, since we're doing and, let's see which one we have in common right here. So we don't have 2 to the 5 in both. We don't have 2 to the 6 in both. Nor do we have 2 to the 4 or 2 to the 3 in both. But or 2 to the 2. So what we do have in both is just these two. And what we can end up doing is just, and let me just circle them separately. So we have these two. And now what we can end up doing is just adding, take one of these two and just add them. So 2 to the 1 plus 2 to the 0, which just ends up being 2 plus 1, which equals 3. And this is our final answer. So this is a much simpler way of going about it than, converting to binary for both numbers, possibly messing up, taking the result of the operation and then converting it backwards. So in this way, you're just doing summations, and you can break it down into easy, digestible numbers. You saw that in this one, we just ended up taking this number itself, and then we just added a 1 to it since it was OR. So now let's go on to the next one. We have 79 XOR 36. So this is, biggest one that we can fit in is 2 to the 6. And at this point, I'm just going to go through it. So we have 1, 2, 4, and let's see. 64 plus 8 is 72. 72 plus 4 is 76. And 76 plus 3 is 79. So we're good there. Now for 36, we're going to do, the one we can fit in is just these two. So this is 32, and then this is 4. So now let's see, what do they not have in common? Or one way, which I guess if you guys have taken discrete, you can think about it like this. It might be easier, instead of thinking what do they not have in common, let's see what they do have in common and just remove those. So what do they have in common? So they have 2 to the 2 in common. So completely just disregard this, throw it out. And now just add up all of these terms right here. Okay, why is it not changing color? There we go. So you just add up all of these terms right here, and that will be your answer. So then we're gonna have 64, so 2 to the 6, 2 to the 5, plus 2 to the 3, plus 2 to the 1, plus 2 to the 0. So even for these right here, there's an easy way to calculate this. You don't have to like do the math out yourself. If you think about it, we have 2 to the 5 calculated. So this is just an easy substitution, 2 to the 5. So we just mark this in yellow. So this one we're good. And now for the other numbers, what we can end up doing is just, let's use a different color. For this range right here, we know that we only remove one value, and that was 2 to the 2. So what we can end up doing is just doing 79 minus 2 to the 2, which is 79 minus 4, and that just equals 75. So we can just say that everything in blue adds up to 75. So really we just end up with 75 plus 32, and this is just going to be 107. Now let's go on to the last two questions. So we have 13 left shift 3. Left shift 3. So this is actually one of the easier ones. So the formula, or the way I like to look at these, is when you have left shift, you have a number n, left shifted k times, and this is equivalent to n times 2 to the k. So all you have to do is just do 13 times 2 to the 3. We know that 2 to the 3 is 8, so 13 times 8, and then this is going to end up being 104. So 13 times 8, it's going to be 80 plus 24, 104. So that was pretty quick. And as for the last one, then we're doing an we're doing a right shift. So 187 shift right 4 times. So 187 shift right 4 times. Now this one typically is a little harder to calculate because people end up calculating the bitwise and then shifting it down, but I'll show you guys an easier way. So just like the left shift, there's a way to look at it. So we can look at it like this: n right shift k, which is equivalent to n divided by 2 to the k. So what we can end up doing is we can use the same strategy as the other ones, unlike the other ones like OR and XOR. And what we can do is just put this in terms of powers of 2. So the biggest power of 2, remember we're looking for 187 such that the biggest power of 2 such that this holds. So that would be 2 to the 7, which is 128. And now if we do 187 minus 128, we're going to end up with 59. So the biggest power of 2, now we're going to apply the same thing. So let's find the biggest power of 2 such that this holds. That's going to be 32. So 2 to the 5. And now apply the same thing. So it's going to be equal to 37. So the biggest power of 2 while this holds, which is oh, sorry. This is not 37. This is 27. So we're going to find the biggest power of 2 such that this holds. And so that's going to end up being 16. And we're going to keep going. So now at this point we can break down 11. I'll just speed it up a little. We can break this down into 2 to the 3 plus 2 to the 1 plus 2 to the 0. So this is 8 plus 2 plus 1, which equals 11. So we'll just end up writing that. Plus 2 to the 3 plus 2 to the 1 plus 2 to the 0. Okay, so now that we've done that, we're shifting to the right by 4. So we're going to be shifting to the right by 4. So this is actually really easy to do. So normally you might have to calculate or put into binary, but the easiest way of doing this is the following. So you're going to take your k and just subtract every power by 4. Now, what you're going to end up doing at this point is any power, so let me just write this down, any power after subtraction that is negative, meaning the power, so let's say k sub I is less than 0, disregard, so set to 0. So effectively you can just throw it away, so throw away. So what that's going to look like is, let's just calculate this. So it's just going to end up being 3, it's going to end up being 1, this is going to end up being 0, and this is where we're going to get -1, -3, and then it's going to be -4. So all of these, we're going to throw them out. So let's just put this in red. So we're going to throw out all of these. We don't care about them anymore. And now at this point, what you're going to end up doing is just taking the sum of what's left over. So now we have, from right up here, we have 2 to the 3 plus 2 to the 1 plus 2 to the 0. And that's just going to be 8 plus 2 plus 1, which is 11. And this is going to be the result. So let's see if we got the answers correct doing this way. One sec. There we go. Okay, this is the wrong question. Let me go to the correct question. So 57, 3, 107. What was the last one? 104. And then now the last one is just 11. There we go. So 57, 3, 107, 104, and 11. So this definitely works. And look, they ended up doing it with binary, but this is much easier to think of it like this. So now I'm going to run through another question just so you guys can see the process one last time on different numbers. Okay, so we're doing OR. So let's just see. They don't have 2 to the 6 in common, so we're going to have 2 to the 6 plus, and then they have these two in common. We're just going to add in 1. So now we're going to have 2 to the 5 plus, and then what they don't have in common, since this is OR, we're just going to take everything else. 2 to the 3 plus 2 to the 1 plus 2 to the 0. And again, we can just use what we've calculated to make it quicker. So notice how we have 2 to the 5, 2 to the 3, 2 to the 1, and 2 to the 0 right here. So that means all of this is just equal to 43 plus 2 to the 6, we have it calculated, 64, and that's equal to 107. So that's it. That's all you got to do. Now for the next one, 117 and 74. So the biggest power is going to be 64. 64 plus, and the next biggest is going to be 32. So right now we're at 96. The next biggest is going to be 2 to the 4. And now we are at 112 plus 2 to the 2 plus 2 to the 0. So this is 4, and then this is 1. So we have 96 plus 16, 112, and 112 plus 5 is going to be 117. And now we have 74, 2 to the 6 plus 2 to the 3 plus 2 to the 1. So 64 plus 8 plus 2, which is 74. 64 plus 10. Now we're doing AND. Let's see what they have in common. So they have these two in common, and that's it. So our answer is just 64. Done. Let's go on to the next one. 76 and 49. Or 76 XOR 49. Two to the 6 plus 2 to the 3 is 8 plus 2 to the 4, or sorry, 2 to the 2, which is 4. Now 49, so that's going to be 2 to the 5. 2 to the 5 plus 2 to the 4 plus 2 to the 0. So this is 32 plus 16, which is 48, plus 1, 49. And since we're doing XOR, let's see what they have in common, and then disregard those. So they have nothing in common. So what that means is everything that's left over, we just add. And if you think about it, since we didn't exclude anything, all we have to do, we don't have to do any extra math except just add them together. And this is going to be 125. And that's it. Let's say they did have something together. What we would end up doing to calculate it, we would just subtract out what they had in common and then add the numbers, and that's it. So subtract out what they had in common between both and then just add that. And the last two is 11 left shift 2 and 330 right shift 8. So 11 left shift 2, which is just equal to 11 times 2 to the 2, which is just 11 times 4, which is just 44. Done. Now we have 330 right shift 8, which again, this is just equal to 330 over 2 to the 8, which is equal to 330 over 56. So the way I would calculate this one is you can end up just subtract, you can end up just flooring it out. So for example, one way you could end up doing is just 1, but I would not go this way. You could, but me personally, I prefer to just do the same strategy. Even though it might take just a little bit longer, it's a nicer way of doing it, and it's easier to verify. So 2 to the 8 is the biggest power, such that this holds. Now if we do 330 minus 256, it's going to end up being 74, and the biggest power such that this holds is 64. And again, subtract that 64, 10. And now from here, the biggest power such that this holds is 8. Subtract that 8. And then we have just 2. And the biggest power such that this holds. So let's just calculate these two real quick. Let's just add them in. So 2 to the 3, which is 8, plus 2 to the 1, which is just 2. And now from here, what you're just going to end up doing is subtracting out k from these numbers. So minus 8, minus 8, minus 8, minus 8. Everything that goes negative, forget about it. Right? And now we're going to have 2 to the 8 minus 8, which is just equal to 2 to the 0, which just equals 1. And that is our final answer. So now we just did all of them pretty quickly. And let's see. So we had 107, 64, 125, 44, and 1. So let's check our answers. So let me just make this a little bigger. Okay, so 107, 64, 125, 44, and then we have 1. So yeah, me personally, I think this is a very easy way of doing this. And you just have to know the very basics of how each operations work. So if it's OR, and you have one in common, or multiple powers in common, just add one of them. Meanwhile, if you're doing AND, just add what they have in common. And a lot of times with OR, what ends up happening is you have the numbers composed for the most part. So in this case, we just took 43 because we just took one of them and just plugged it in for right here. Alternatively, you could have just done 96 plus 11, and that would have given you the same answer. If you have XOR, you find what they have in common and exclude them and sum the rest. And in this case, to calculate what the answer would have been, we just take the main value, so 79, and subtract out what we excluded, so 4, and we end up 75, and then add that to what's remaining of the other number. And yeah, left shift, just this formula, and right shift, this strategy. Just subtract out, and then this is your final answer. So I hope that helped. It seems like a lot, but trust me, once you start doing it, it's way quicker than it seems. I was just going slow, but you saw how quickly I was able to do these right here. Yeah, hope that helped. Peace.